How to identify the area, base, and height of a triangle. A triangle is half of a parallelogram. As we can see here, we have two parallelograms, but if we split those parallelograms in half, you'll see that you have two triangles. Two identical triangles here. And for this one, same idea. If we split these triangles in half, we'll see that we have two identical triangles. Okay? And so again, a triangle is half of a parallelogram. Now, in the video, how to find the area of a parallelogram, we learned that the formula for finding the area of a parallelogram is area equals base times height. So if a triangle is 1/2 of a parallelogram, then the formula to find the area of a triangle is area equals 1/2 base times height. Again, the area of a triangle is half of the area of a parallelogram, so we only need half of this. And I just want to remind you that when we talk about area equals 1/2 base times height, area is represented by a capital A equals 1/2. Base is represented by a lowercase b, and height is represented by an h. Now, before we go over finding a proper base and height pair for a triangle, we first need to go over a few basic facts about triangles and some vocabulary about triangles. Now, a triangle has three sides. 1, 2, 3. And these sides meet at points called vertices. All right. And so when the sides meet, that is called a vertex. That is a vertex. Vertex and a vertex. We say vertex when we're talking about one, and we say vertices when we're talking about more than one. Now, a proper base and height pair on a triangle is similar to a proper base and height pair on a parallelogram, in that any side of a triangle can be its base. Also, similarly, base and height must meet at a 90-degree angle. They must be perpendicular. And the height is measured to the height of the opposite vertex of that base. And I'll show you what I mean by that as we get into it. Okay, let's say that the bottom side of this triangle here is the base. All right. Again, any side can be the base. Just depends on how you're looking at the triangle at that time. And so just for this example, let's say that the bottom is the base. Great. What do I know? Any side can be the base. Bottom is the base. What else do I know? Base and height must meet at a 90-degree angle. And so here's my 90-degree angle. I'm going to set it up as a base. And if you're doing this like at home or at school, and you want to make a 90-degree angle, you can use a card or a piece of paper to make a 90-degree angle. Okay, and so I set my 90-degree angle up on my base because I know my base and my height have to be perpendicular. They have to meet at a 90-degree angle. And so I here have a base. Now I have a 90-degree angle. And I'm going to make a dotted line where my height is at. And so if this is the base, then my height is going to be perpendicular to the base, 90 degrees from the base. That is my height. And now the other thing about my height is the height is perpendicular. We got that part. But the height has to be measured to the height of the opposite vertex of that base. And so if my base is at the bottom of this triangle here, where is the opposite vertex? Well, I have a vertex here, and I have a vertex here. What is the opposite vertex of this base? It is the vertex that this base does not touch, which would be here. Okay, and so that means my height has to go up to that point. Okay, let me show you what I mean. My height continues up to the point of that vertex. And so this line here represents the height of the opposite vertex. This dotted line represents the height that corresponds with the base there. All right. And so I'll put a H next to here just to show that this represents height. That would be my height, and this would be my base. We're not going to associate numbers with it right now because we just want to kind of show how to find a proper base height pair. Let's try another one. All right, let's take a look at the same triangle, but this time, because our base can be any side, we're going to look at our base as being this side over here. Okay, on the right side of the triangle. If our base is the right side of the triangle, how can we find a height to go along with that base? Well, what do we need to know? We need to know that base and height always meet at a 90-degree angle, right? They're perpendicular. Okay, and so I'm going to take my 90-degree angle. And again, if you need to do this at home, you can use an index card or anything with a 90-degree angle that lines up with your base. Here's my base on this side, and there's my 90-degree angle. All right. Now, the last thing I need to know, the height of the triangle is perpendicular to the base and is measured to the height of the opposite vertex. So I need to figure out what is the opposite vertex to this base. Okay, and so where are my vertices? I have a vertice here. I have a vertice here. And I have a vertice here. And so which one does not touch the base? That is my opposite vertex. This touches the base here. This touches the base here if this is my base. And so my opposite vertex is on the other side of the base, which is here. Great. And so that's how high my height has to go. And so I have my 90-degree angle. And I'm going to draw a dotted line up to the opposite vertex, the height of the opposite vertex. And so here, again, I have this dotted line is my height. And this right side of the triangle is my base. All right. Now, I do not necessarily have to go directly to the opposite vertex. Let's say that I move this angle over just a bit. Okay. Let's say I shifted it just a bit. All right. Now my base is still in the same spot, same right side of the triangle, but I want to know what my height is. I have a 90-degree angle, so my base is perpendicular to my height. Now my height needs to reach to the opposite vertex. We've already established that this is the opposite vertex. Here, this is the opposite vertex. And so my height needs to reach to that point. So I'll draw a dashed line from my base at the 90-degree angle up to the height of this opposite vertex. Okay. And as you might have noticed, if you go back a little bit in the video, you'll see that that is the same height as this. And so you'll always get the same height when you have a 90-degree angle at the base running perpendicular to the height of the opposite vertex. Now, what if the left side of this triangle were the base? Well, it is the same process, Base and height must meet at a 90-degree angle. All right, must meet at a 90-degree angle. And so we take our 90-degree angle, we line it up with our base. Okay. And then we ask ourselves, what is the opposite vertex to the base? All right. And so here we have a vertex. This vertex is touching the base. Here we have a vertex. This vertex is touching the base. What is the opposite vertex to the base? The one furthest away from the base is here. And so that means that my height has to go 90 degrees to the height of the opposite vertex. All right. And so this would represent my height, and this would be my base. All right. And that is how you find proper base height pairs. Okay, so once you have identified a proper base and corresponding height, you follow the formula for the area of a triangle, which is area equals 1/2 base times height. Just as an example, let's say our base was 10 and our height was 3. What that would look like is area equals 1/2 multiplied by 10 multiplied by 3. We do what's in the parentheses first. So my base is 10, my height is 3. That's 10 times 3. All right, that's 30. And so area equals 1/2 times 30. Remember that multiplying by 1/2 is the same as dividing by 2. And so we have area equals 30 divided by 2, which is the same thing as 30 times 1/2. And my area would be 15 square units. All right, 15 square units. Again, because we're talking about area, it is square units. And so let me just fix that right quick. 15 square units. All right, thanks for watching.